Today we're working on a restaurant application. We start with a database and a restaurant class and a simple API to create and query the restaurants. We have a nice end-to-end test to make sure that works. I want to explore what happens when we expand this application by using test-driven development. We're going to create extra fields, validation, and new entities with database tables. So let's start by reviewing the code that we already have. This is our API endpoint. Currently, this application is only an API. We are exposing restaurant data over API v1 restaurants. We can create a restaurant and we can look up a restaurant. A restaurant simply has an ID and a name currently. We have some simple from and to JSON objects. And we have some code which can convert these in our API. The startup is very simple. We're using Flyway to manage the data schema, so we can have a look at that here. We've got one table, it's called restaurants with the ID and name. And we have a connection pool, and finally we start the server and register everything. Okay, let's run the test and have a look at that. This is an end-to-end test. You can see when we set up the test, we create an embedded database, we start the app, get an HTTP client, and we create a restaurant object. We send this as JSON into the API. And when we query it back down here, we make sure the JSON we receive is the same as the original JSON we sent. Let's just make sure that works. Okay, test passed. So I want to add a new field to the restaurant object first. Let's just add a description to it. So we're just going to make some dummy description here. And the rest of the test still stands. So if we create a restaurant with the description, all the best roles, when we post that, we should be able to get it back when we query it again. And the object we get back should be equal to our original object. This proves that serialization and deserialization works along with the database code and the API endpoints themselves. Okay, so first of all, we need to add the new field to our DTO object called restaurant. So let's add the string as the third record. So we are going to call this description. Okay, so now at least our test should not compile. Okay, so immediately our compiler is helping us to sort out our new code. And here is the place it's complaining. This is our database code. We look up a database based on an ID, simple SQL, and we convert the database row into a restaurant object. Let's spread this out a bit so we can see easier what's happening. Okay, and we just need to get the description. We haven't added this yet to our database, but let's assume it's called description. And now we get to another issue. This is in our restaurant DTO object, converting a JSON object into a restaurant. So similar idea. Let's come in here. Let's assume that's going to be called description. Okay, hopefully we can compile now. Okay, good. And I wanted to see the test fail because we expected when we created this a description to be all the best roles, but it is an empty string. So to make this test pass, we really only need to do a couple of things. We need to improve our JSON generation. So we can add the description just like that. And we need to change our database table. So this was version 1 of our database table. We're going to add version 2 now. So let's create a new file called v0002. And this is called add description SQL. And we're going to alter the table restaurants And we're going to add a column called description, which is text. And we're going to need to make this nullable because we may have existing data in our database. Okay, now we need to use this from our database code. We have this restaurant DB object. Okay, we've already added the description there when we're looking up. When we're inserting though, we also need to insert this. So let's just go description. Now we've got 3 values. And similar to how we set the name, we're going to just set the description. Okay, maybe that's enough. Maybe it'll pass. Cool, and that's how we add a new field to our database. Next thing I want to do is improve the error messages when people put invalid data into our API. So let's see how you can do that with test-driven development. So I'm going to duplicate this test. Okay, and we can just call it, say, if 400 is returned if there is no name when creating a restaurant. So what we want to do here is send a restaurant object without the name added. So let's just call this the request body. It's the restaurant.toJSON. And then we want to remove the name field from the JSON. When we create a new restaurant, we want to use this JSON now. So we can select that and we convert it to a string for our API. And we want it to be a 400. And we also want to make sure the error message is nice. I'm just going to delete all this extra code here. So let's just assert that the response body contains a nice error message. I won't care about the format for now. So we'll just say response to body contains the string, let's say no name specified. Okay, so this is our test. It's quite nice and straightforward. So let's run this and we assume it's going to fail. Okay, let's look at the error message. We expected a 401, but actually it worked. So it's probably inserted a restaurant into the database with an empty string, which ain't so good. So now let's make this test pass. The restaurant object is created calling this static method, so perhaps this is a good place to throw exceptions from. And the code which calls this method is this body reader. So this is also a place that we can throw an exception from. I'm going to keep our API type exceptions separate from our just straightforward Java exceptions. So let's see, we want to grab a reference to the name like this. And we're going to say if name is blank. This will never be null, by the way. Opt string gives a empty string if nothing's set. And let's throw a new illegal argument exception. Okay. Let's just change this to our expected one. No name was specified. You know what? I prefer this. Okay. Let's stick that there. Right. So if we run it now, this code should get invoked. However, our test should still fail. So we can see it is here. We are throwing this illegal argument exception, but we need to convert it into a web application exception. Otherwise, the client gets a 500. So we can do that down here by wrapping this in a try catch. So we're going to catch illegal argument exceptions. And if we do, we're going to convert those into bad request exceptions, and we're going to assume the message is okay for our consumers. Let's rerun that. Okay, and the test passes. That's nice. It's also a good idea to just check the JSON is valid and also return a 400 if it's not, especially if your API will be used by a lot of people. You'll be surprised how many people send invalid JSON. So let's change this a little bit. we don't need to worry about creating a restaurant at all. We can simply send some invalid JSON. Invalid JSON, that is invalid JSON, okay. And here we can just say invalid JSON format. Okay, that'll do. Let's run that. Let's see what happens if we don't have this implemented. Okay, we're going to get big stack traces in our logs, which are ugly, and the user is going to get a 500 back. The 500 would mean it's our fault on the server side, but this is not. This is the user's problem, so it should definitely be a 400. So let's come back to this class, and this, or perhaps this, is going to throw a JSON exception if it is invalid. So let's just do that. And I've forgotten what message we want to send. Okay, invalid JSON format. So there we go. Let's run that. Okay, lovely. The test passes. Let's make sure all our tests pass still. So I'm going to run them all. And great, they're all passing. And look how fast they are, 6 milliseconds, 4 milliseconds. The first one is the startup time, slightly slow, but after that it's very fast. So remember, these are end-to-end tests. You may be noticing we're not writing any unit tests. We're not mocking anything. Every test can be end-to-end. This is going to give us a lot of confidence that our application works as expected. Right, when you've got a few tests passing, it's always good to come and look if you can refactor anything. And I think we can see a lot of this test code is this send method. Sorry, this send method. So how about we extract this into a new function? So I'm going to start with the last one because we're just passing it a string. So let's grab this and press Ctrl-Alt-M, and we can call this, say, create restaurant. Okay, and I want to pass the string into the body. Okay, body, good. Now, IntelliJ is saying, hey, this is kind of similar. Do you want to do that here as well? Yes, please. And this other test, yes, please. Okay, nice. So our third test here now is very nice and small. This one with an invalid name is also rather charming. And this is still the biggest one where we're doing the most. We better make sure things are still working. And there you go. Lovely. Right, let's commit our work. Okay, we can create restaurants now and look them up from our API. Obviously, a restaurant needs food, right? So menu items. We're going to create a new table called menu items, a new data object and database classes, and we're going to test that we can create and look up menu items for a restaurant. So let's get started on that. First up, we're going to create a new database table. So we're going to call it B0003, and we're going to call it menu items.sql. So we create table menu items, and we're going to have an ID, which is a UID. It's the primary key. We're going to have the restaurant that this menu item belongs to, so that'll be a restaurant ID, which is a UID, and it's not null, and it references restaurants ID. Has a name, has a description, and we have a price. I'm going to store this as cents, so we're assuming it's dollars here, and this just avoids any precision errors we have, so we can call this a big int. It's also not null. Okay, so there is our menu item. We're going to create a menu item data class. So let's select those. Let's create a new Java class called menu item. We make that a record. Right, so that's got these values on them. Let's just get them all there. Right, these are going to be, well, different types of objects. Let's get to that in a second. So The first two are UUIDs. These two are strings. And this is a long. Okay, we want to convert into Java convention here. So for the underscores, if I press Alt-J, I select them both, delete them, and I want to convert those to uppercase. Okay, lovely. Clean up the formatting. Okay, and we're going to need to convert these to and from JSON. So let's create two JSON first. And we're going to put all these into the JSON. So let's select all those. We can paste them there. System will go to output. There's our two JSON. Okay, similar for from JSON. This is static. So this creates a menu item from JSON. So we're going to be getting these out again. I'm going to select those, column select, paste them in, and all of these are going to be JSON.draw required. So they're all going to be get something, fill in the somethings in a second. Right. So the first one is a UUID. There is no UUID method. So we need to get them as a string. Both of them are like that. So we're going to go UUID.from string. Okay, good. These two are names. Good. Okay, and this is a long, as it's in sense. Okay, to and from JSON, done. Our data class is ready. Before going further, let's actually add the test. So let's duplicate this test. And we'll say can create restaurant and add items. Okay, we can keep that restaurant, that's fine. And we create it. We are already asserting these in another test, so we don't need to duplicate those. But we could just assert that we get successful result back. Okay, so sorry, the create restaurant returns a response, so make sure we get 201 back. Okay, so we want to do something similar as create restaurant. We want to basically go response is equal to create menu item, and we're going to pass it an item. Okay, so what does an item look like? It has a UUID of the item itself, create a random one, has a restaurant ID, okay, it's got a name, description, how do you describe perfection? Okay, and let's say it's $5. Okay, so given a menu item, we want to be able to create it just like that. So let's create a method like that. This is going to return so we need to make a request to create this menu item. The URI is going to be the apps URI.resolve, and we just want to post to menu items. Okay. Big I, thank you. The format we expect back is JSON. Content type we're sending is JSON. And we're going to post the JSON to it. So we can simply send this with our client. And we have to say that we expect a string back. Okay, and throw exceptions. Let's just assert for now that the status code we get back is a 201. Okay, so we can run this test. We can see it fails. There is no API on that endpoint. However, we should see now that there's now 3 schema upgrade files being run. So our database, when we run this, will have the menu items added. Okay, so let's make this test pass. We're going to need a menu item resource. And this path is on API v1 menu items. And we have a post endpoint. It produces application JSON. It consumes application JSON. And it creates a menu item just like that. And for now, let's just return the menu item without doing anything. So when we run the test, it fails. Now we need to register this resource onto our web server. So we can come to our application class. We have a REST handler here. Our REST handler takes an array of REST resources. So we can simply create another one like that. Okay, and the test fails. And we're getting a 415. This basically means our web server does not know how to deserialize these menu items or create these. So we're going to need another message body reader and writer. Now this was our restaurant body reader, so we can certainly copy this like so. Select all the restaurants. Too many. And replace them with menu items. This will probably work. And we register this with another custom reader. Now let's see if that actually works. Okay, so it's got a bit further. Now it's complaining it can't write it. So we're also going to need a writer as well. So let's assume we're going to create a menu item body writer. And we're going to duplicate this. Once again, we can find all the restaurants. Okay, and place them as menu item. And hey, this might actually work. And it basically did. We were just expecting a 201 and got a 200. This solves the problem immediately, but it's not very nice, is it? Most of these classes are exactly the same. There's a lot of duplication. If we're creating 10 different tables, I don't want 10 of these. So perhaps now is a good time to refactor this. So if restaurant and menu item both extend a common interface, and let's say that is something that can be converted to JSON, like for example, JSONable, then we could just create a message body reader and writer for JSONable. If we look at our restaurant class, the instance method that's going to be common on all of them is this toJSON. So let's say that is a method on our interface. Don't need public. Okay, so if we make this implement JSONable, so we can see we're overwriting that now, and we can do the same for our menu item. There's no other change there. Now we can come back and grab a body reader. So let's put it in the JSONable file. And we're going to select all of these restaurants again. Okay, and we're going to call it JSONable. And we'll see we quite quickly hit this problem. So this is a static method. So this is the one place where we need to know what the actual type is. So we can say if type is assignable from restaurant.class, then we can return restaurant.fromJSON. Okay. Else, if type is assignable from menu item.class, let's copy that. And we're going to return menu item.fromJSON. Right, we can pull this out here. It's just the JSON. Else we can just throw in a legal state. We don't expect to ever hit this until we add a new type, and our test very quickly tell us there is a problem. Okay, we're going to need to do something similar for the writer class now. So I'm going to go back to our restaurant class and find the restaurant body writer. Let's grab that. I'm going to paste it into our JSONable file. And once again, pick up the restaurant class names, and we're going to call this JSONable. Okay, this one too can be JSONable. And this time it's actually easier. This thing can write any just JSONable class, and it doesn't need to know what the type is. Okay, very quickly, we can make this a little more efficient by not creating a JSON object, converting it to a string and getting to the bytes and putting it on the entity stream. The entity stream is an output stream. What we can do instead, let's go JSONable.toJSON, and then we can write it to a writer. So we just need a writer. Let's create a writer here. That is a new output stream writer, which takes the entity stream. And we can probably wrap that in a private resources. Lovely. Okay. So now we can delete all this other code in the restaurant class, which is nice. Let's delete, 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 delete all of that. And our restaurant class now is nice and simple. It's just got some JSON handling. Otherwise, it's a straightforward record. And in our application, we are going to register the JSONable body reader as a reader, and the JSONable body writer as a writer. Let's go back to our app test and see what happens when we run all of them. Let's just make this at 200 for now, see if everything passes. And nothing passes. Okay, so let's figure this out. We're getting 415s, so perhaps this is related to the reader. So we stick a breakpoint there. Let's have a look. Okay, the type is a restaurant. Let's see what happens when we execute this. Let's copy that, press Alt F8, evaluate that, and that is false. Now I normally get this around the wrong way. Perhaps it is JSONable class is assignable from type. True, right, that is the problem. Okay, so we're going to come here, replace that with that, and a bit I've got it around the wrong way in the writer as well. Yep. So let's copy that to the type. Okay, and rerun. Okay, now that passes. Let's make sure everything passes. Okay, so now we can see in menu items back and forth over our API. Let's make sure this test covers everything we need. So we want to be able to create an item. So when we do, we expect a 201 back when we create an item. And let's make sure we can query this item back. Okay, so let's create an HTTP request builder, which has the app URI dot resolve API v1 menu items / item.id. That is our request. We can stick this directly into our client and send it. We just need to make sure we're getting a string back like that. Okay, and this is our response. So we can assert that the response to status code is 200. And we can also assert that the menu item from JSON with the response body is equal to the original item we put in. Let's have a look. We expect this to fail, of course. As expected, it's failed because we're not returning a 201 from our resource. So let's change this to return a response. And for now, I'll just return a 201. Oh yeah, let's put the JSON as the entity as well. Okay, we still expect a failure, but for a different reason. Yep, it should be a 404. And note, we've passed the wrong value to our entity. Okay, this time. Now we expect a 404. Yep, because we do not have an endpoint for this method. So this is a get method. It's listening on a path. So we join the path API v1 menu items / menu item ID. It's going to produce application JSON. And it's going to return a menu item. Okay, just like that, except it is a UUID. And now we need to look up the class in the database, which we don't have. We do have a restaurant DB, and this is going to be very similar to our menu item DB. So let's just copy and paste. And the main bits are the restaurants. So let's replace restaurants with menu item class. And we also have some lowercase restaurants. Let's see where those are. Okay, in SQL, so menu item. Okay, we're some of the way there. We just need to sort out some of this and some of this. We can come to our database table here and get the column names. We want a comma separated list of these. So we can create a new Scratch file, just plain text is fine. Column select, delete the new lines, put a comma in the space, paste that in. Okay, we've got 1, 2, 3, 4, 5 columns, so we need 5 placeholders. Okay, so we've got our parameters here. Now rather than 1, 2, 3, let's just go var I. Let's start at 0, and we're going to pass this in, increment I by 1 each time. Okay, so the first one is the menu item ID, the second one is the restaurant ID, then we've got a name and a description, and a long. Okay, that's great. Next up is a getting one, so we're going to select from menu items, and we've got a similar deal over here. We're getting an ID followed by a restaurant ID, and then the name, the description, and then the price in cents. Okay, I think that looks pretty good. We got a menu item DB now. So our menu item resource wants this. Use constructor injection by creating a menu item DB, we'll call it DB, and we'll ask it to be added to the constructor parameter. So now when we get a menu item, we can simply go db.getID. Now this may be null. If it is, we're going to throw a new not found exception. Okay, that'll do. Otherwise, we just return the menu item and we throw exceptions. Okay, let's try that out. And constructor injection, well, we got to pass in the database class to our menu item resource. So let's call that a menu item DB and pass it the connection. Now we run. Okay, let's see why that failed. So relation menu items does not exist. Okay, we've got a SQL issue in our database, and yeah, table name is incorrect. So that's the select one. What about the insert? Also incorrect. Okay, let's try again. Now we get a 404, and that is probably because we're never inserting the object. So we're probably just looking it up and getting a 404 back. So we can come back to this place here, and we call insert on the item, throw exceptions, and we're done. We've got a passing test. So now we can create menu items, look them up. Let's just add one more endpoint to let us look up all the menu items for a restaurant. So we come to our test. So here we've created a new item. Let's create item 2. So item 2 is down here. Let's call this a sausage roll. Let's say that costs $4. Okay, so when we create it, we get 201 back. Now what I want to do is see if we can query all of them back for a single restaurant. So I'm going to want something similar to this. Let's call this the filter response. So instead of looking it up a single ID, let's look up by restaurant. restaurant ID equals item dot restaurant ID. Okay. And for now, I'm just going to write this directly. So let's create a JSON object with the body. And let's say the JSON has an array called results. Yep, just like that. And what we can do is loop through the results as a list. We can then stream that and then map each item in the results to a JSON object and convert that to a menu item object. So let's assume this is called O. We can go menu item dot from JSON, and we can just cast that to a JSON object and then just make that a list. Now we haven't said anything about the order that these should go in. We could slide that later, but for now we can just assert that results contains in any order item and item 2. Okay, so what is this test doing again? It's creating a restaurant, it's creating 2 items, and then it's making sure we can query both those items back just by filtering on the restaurant. Okay, and it fails because it looks like a JSON exception, but if we actually assert that the response code is 200, I think we will find that this is a 404 as well. There's actually a 405, which is a method not allowed, and that just means we have probably matched this endpoint here, and this is a post only. We're trying to call a get on it. Basically, we're missing a getter. So we're going to have a get. Again, both this post and the get have no path, which means they're just on API v1 menu items. This produces application JSON, and we're going to just return a string here, and we're going to call it filter, and yeah, let's filter by the query parameter restaurant ID. So we're going to need a list of matching menu items from the DB. So if we call db.filter and pass in restaurant ID and say, well, we're going to have a list of menu items. Okay, and we just need to implement this. So we create a method in here. This is the restaurant ID. And this is going to be similar to our getter. So before I copy and paste this, I'm going to extract this part here, which converts a result set to a menu item. So let's call this row to item. Okay. And now I can copy this into our filter, throw the exceptions. Okay, so now we are searching by restaurant ID. The parameter one is restaurant ID. And instead of an if else, we go while. Okay. And we can make, say, an array list of menu item. We can add it to the item and return it. Okay. So now we've got items. Remember from our test, we want to have a JSON object with a results array. So let's just return a new JSON object. We're going to put results in there. We're going to create a JSON array, and we're going to loop through our items. We're going to stream them out. We're going to map each item to JSON. Okay, to list, right? And call to string K. We can probably simplify this a little bit. And let's rerun. Okay, that doesn't work. So JSON object results is not a JSON array. Okay, and that's because I made a typo here. Okay. Still doesn't work. Okay, hash map cannot be cast to a JSON object. Okay, and this is because toList converts this to a hash map rather than a JSON object. So maybe we can create a new JSON object from the hash map. Okay, this is a bit ugly, but hey, it's working for now. One final test to make sure everything works. And okay, that's done. So we're building up our application nicely now. We've got some good end-to-end tests. We've got 2 database tables. Our API is getting bigger, and we can just iterate on this on, and we're going to have some great test suite here. Once again, rather than having a few end-to-end tests and lots of unit tests, we've flipped that upside down. We've got 100% end-to-end tests, no unit tests. Occasionally, I find myself adding unit tests around perhaps some tricky regular expression validation or some little function that has many different types of inputs. But as a rule, I'm going end-to-end all the way. Everything is super fast and gives us super confidence that we won't introduce bugs as we iterate on this application. As usual, the code is available on GitHub. That link is in the description. Happy hacking!